Hello and welcome. I am Vishwanath M. In this video, let us try to learn and understand the fourth program of Artificial Intelligence and Machine Learning Laboratory of VTU. The program is titled ID3. Now this program will be easy and will be practically possible to write and execute only if we know the working of the algorithm really well. Now ID3 algorithm is a very important topic in theory as well. We will get at least one problem wherein we will have to use the algorithm to solve the problem and finally get an output which will be a decision tree. Now let us get a basic introduction of this ID3. Basically ID3 means iterative dichotomizer tree. Now let us not worry too much about the name. Basically dichotomizer means it iteratively divides the data set into two or more groups. Now this becomes meaningful only if we know the algorithm well. So this is the easiest way of writing the algorithm. What we do while theory is we find the information gain of all the attributes in the data set. Then we choose the attribute with the highest gain as the root node. After that, we repeat the procedure until it is done. When can we say that it is done? We will conclude when the leaf nodes will have the target value. So let us see what the third step says. We will create a subtree for every possible value of the chosen attribute. And if the entropy of a certain value is 0. Now when will the entropy of a certain value be 0? When all the rows will have either yes or no. That is what this statement means. So when the entropy is 0, we create a leaf node with the target value as the label. Now what is label? It is yes or no. If we don't have such a thing where the entropy is 0, what we just do, we create a subset of the entire data set and then we do the same thing again. We find the information gain of all the attributes except the attribute we have considered above. That means while we are branching in the tree, whatever attribute we have chosen in the step above, we don't take the attribute again. That is what the second step means. And the same thing happens. Just choose the attribute with the highest gain at that particular level. Now this is the basic ID3 algorithm. ID3 algorithm finally returns a decision tree. Now this is extremely useful and required in while learning the program as well. Let us just see how the output will finally be. Now this is what we get while we are writing in the theory exams. This will fetch us nearly 10 marks. Now this is the decision tree. So all the items written in the box are basically the attributes or the column headers, we can say, and these are the values, and whatever is written in this rhombus like structure, diamond like structure, they are the labels. We have I said here we when the entropy is 0, we say that we create a leaf node with the label. So these are the labels, yes no, they are the labels. Okay, now this is also extremely required and useful. And while solving, as I said, we came across two terms. One is entropy, another one is information gain. Now what do they actually mean? We have a formula for them. Now these formulas are relevant to us only if we know the theory well, because this is what we use while solving the problems. Entropy of S is the data set. We do P plus is like the number of rows in which the outcome is positive, and minus P log of P plus minus P minus log of P minus. Now this is the formula we need to memorize. This is the standard formula of entropy, and this is what we use in theory as well. Now what is the formula for gain? Gain of the data set, and gain will be relevant to a particular attribute. So gain of the data set for a particular attribute A, what we do is we first take the complete entropy, that is the total entropy of the data set, and we subtract this thing. So now the derivation of why gain looks like this is itself a long procedure, but we need to remember this SV by S into entropy of SV. What is this modular sign? It means the cardinality of S. Now suppose if S is a set, mod S will give the number of items in the set, and V is the values set of A. What does that mean? A is an attribute, and what are the possible values A can take? That is V. Now this is one thing which we need to know. and there will be independently functions by themselves in this program. So knowing this formula will be extremely helpful. Now let us get into the program. Now the best way to learn the program is to trace it. In other words, we will learn the program by going to the program in the way it is executed. Okay. Now we see two terms called train tennis and test tennis. Now they will be given to us in the exam. Basically they are data sets, CSV files. The same can be seen here. This is train tennis data set. Now this is a very popular data set. We use the same thing for the theory exams as well, which will have 14 rows. It is like a standard example. So we just load, so we call the function load CSV on the train tennis function, train tennis data set. What this load CSV will do, we will just see now. Load CSV is a function which will take a file name. So file name can be either train tennis or test tennis. What it will do then, it will just use this CSV module csv.reader. It will open the file in read mode and it will process the entire dataset as a list. What does this headers mean? Headers means the dataset dot pop of 0. That means the dataset will contain everything. Pop of 0 is like the column headers, the attribute headings, outlook, temperature, humidity, wind and plateletness. That is what is stored in headers, and we return the dataset and headers. So now this function is done. So dataset will have the data values and the features will have the attribute headers or the column headers. Okay. Now immediately after this we call the function called build tree. Build tree is the main function or the computationally most important function of this program, ID3 program, build tree. That is, in other words, we are building the decision tree. So in order to build a decision tree, we are passing the data set and we are passing the features. Data set is the entire data and the features is the column headers, and that is quite understandable as well, because the final output is something like this. So it is mainly concerned with respect to the column headers. So we can see the things written in the box are nothing but column headers, and these are the values or data set values, that is the contents of the rows, sunny, overcast. They are all values of these particular attributes. So now having understood that, let us now get into this function called build tree. Now build tree function looks a little long, but we need to know what every line of code is doing here. So why we are taking data and features is understood now. What this last column is doing? Last column is just taking the value for the last column, row of -1. So -1 means the last item on that row. That is a method of indexing. -1 refers to the last column. So in every row we are just extracting the last column value. After that, as you can see here, if the length of set of last column, now this is very important. What is the need of creating a set here? Now the speciality of set function is it will take this last column as the input. This is basically a list of this last column data. This set will create a set which will have the unique values. In other words, now we have 14 values, no, yes, no, yes. Basically the values are only no or yes, but we have totally 14 such entries. What does this set do? It will just create a set which will have no and yes. That is it. So if the length of set of last column, so maximum value of this length of set can take only 2 because it is no or yes. If it is 1, what we do? We will now let us understand what this node is doing. Node is basically a variable. It is an object of type node. So node is a class and we are passing something. So this becomes relevant and understandable only if you know this class well. Now let us get to this class. Class node is basically we are creating a class to in a way represent this node like structure. So this is, we can consider this is a node, this is a node. So in a way we are creating a structure. So we are creating a class, and this init function is like a constructor function. It takes one attribute. The self is not a it takes one parameter. Self is not a parameter at all. Self is like this pointer, which is inherent pointer, and whatever comes in the attribute, we can see that it is being initialized to this member of this class called attribute, and it is having an empty list as called by the member called children, and it is having answer as an empty string. Now this is the basic structure of the node, or this is the explanation of this class node. This needs to be known to us, and this becomes more relevant when we have understood the entire program. That is why we are having this children and why we are having this answer. It becomes more relevant as we go further in the explanation. Now we were here, we have all this node, we have created one variable called node. In other words, we have created one node, and we have initialized node.answer is equals to last column of 0. Now basically what this last column contains, it is either yes or no, and here what we are trying to do here is, now in this case, now this program cannot be understood if you don't know the theory well, if you don't know what does this ID3 algorithm do and what does this output mean. So it is highly recommended to know the theory very well before understanding this program. Now when will this condition be satisfied? We can see when the outlook is overcast. So let us see in the CSV file. Whenever the outlook is overcast, we see that the plateless is yes. We have verified here. Next, the same thing applies here as well, and overcast yes, overcast yes. So whenever there is whenever the outlook attribute is taking the value overcast, final target value is yes. Now that is what we are doing here. So as I said, last column will have only yes or no, and this set of last column will now contain only yes, because all the 4 rows is having value yes itself. So what we are doing here, whenever we get such a thing, when the data set is having the last column only a particular value, that is either yes, either only yes, or either only no. That is what is written in the comments here, either only yes or only no. So we just create one node and we just give the content of the answer as whatever is present in the last column. In other words, we have created one we have given the answer value as yes. That is what is happening in this part of the code. Now after that, what is length of data? Now data, as I said, is nothing but the entire data set, and features is the column headers. And what is this length of data of 0? Now data of 0 means the first row, and length of data means 1, 2, 3, 4, 5. It is totally 5, but we are subtracting 1 because we are not concerned with the last column. Last column is a target value which we process separately. So n will have 4. N is equal to length of data of 0 minus 1. And as I said in the algorithm, we need to, now that is why algorithm is extremely important to know while writing the program. The algorithm says that we should find the information gain of all attributes in the data set. That is the first step in the algorithm. Now that is what we are doing here. We are initially creating one empty list, a list having all containing 0, and then for every column in the range, in other words, for every attribute, we are calling this function called compute gain. Now that is why this image is so necessary here. For every column in the attributes, or for every column, we are calling the compute gain function. That, in other words, we are doing the step 1, find the information gain of all attributes in the data set. Now after we have found the information gain, let us learn this compute gain later, because it is a separate function all by itself. Let us understand it later. So we have found the information gain. Step 1 is done. Next, what does the algorithm say? Choose the attribute with the highest gain as the root node. What we are doing here, gains dot index of max of gain. So you see this max, which means that it is choosing the attribute with the highest gain, max of gains. And it is now this basically what does this split contain? It will have the index of the attribute with the highest gain. That is what the comment says here. And let us just shrink this data set so that the comments become more easily visible. Let us have this algorithm here next to us. Okay, now the split is having the index of the attribute with the highest gain. After that, what we say, we will create a root node. So we are creating node is equals to node of features of split. In other words, we are creating a node which is basically a root node in the first iteration, and features of split means features is a features refer to those 4 columns. In other words, it refers to these, features refer to these 4 columns, the 4 attributes. So what we are doing, we have found the attribute with the highest information gain here in this step, and then we are creating a node for that particular feature. So now the output becomes necessary. So we have found that if we have solved the problem, we will know that Outlook will usually have the highest information gain. So now we have solved up to here. We have created a node with the Outlook as the we have created a node with Outlook as the value. So basically this node will take this attribute, so we have passed it as Outlook. So attribute will be assigned the name Outlook. Okay, now we have understood the program till here. Next, the algorithm is again necessary. After this, after we have made the root node, what is necessary is we need to go further in the tree. That is, we have come to here. Now we need to go further in the tree. What are we doing in this next step? We are creating this variable called FEA. What we are doing is we are splitting, or we are just extracting the features other than the already considered node. In other words, let us go back to this algorithm. Here what it says, find information gain of all attribute except the attribute already upper in the tree. That means already that is considered. So what we have already considered is Outlook. So now we use the features variable, and we use method of slicing up to. So for example, if the split index or split value was something like 2, something like 1, this is 0, this is 1, this is 2, this is 3. If the value of split was 1, what this line of code is doing is it will process the features, so up to this value. So if just for the example I've taken split is 1, so it will come up to here, so this will not be considered. Outlook is taken and split plus 1, in other words 1 plus 1 is 2, and from here to everything. So what we are trying to do here is we are creating a new variable called FEA, which is the features again, but we have not included the one we have already considered here. Okay, now let us go further in the algorithm. What does it say? Again, so basically, as I said, it is from here we just repeat until done. Again we find the attribute with the highest node, and we again build the tree. So this gives a clue that the function should be recursive. Now we can understand the same here for x in the range of length of attributes. Now what is we have to still understand what this subtables is doing. Now what is subtables basically? Subtable, the meaning says a part of the table. That is, in the entire table, this subtables function will return a part of the table in the form of these two variables, attr and dic. What does this subtables do? It is a separate function. We will just understand. Now, subtables is a function which will take 3 parameters. The last parameter is basically a boolean value. It is either true or false. Let us not worry about it now. Data is the data set, and what does this call mean? Now call is basically a column header. In other words, what we are trying to do in the subtable is, so for example, now we have in the first highest gain is Outlook. So we need a table which does not have this Outlook column. That is what we are trying to do here. So you can just see DIC is a dictionary, which we will just create an empty dictionary, and we will have this call data variable, which is basically a list of, as you can see, row of column. So row of column means, now column is a value. For example, if it was Sunny, for Sunny each row we consider. In other words, while we are solving the problem by hand, what we do is we write one table. For example, if it is whenever it is Sunny, we just take all the rows in the data where we have only this variable called Sunny. In other words, what we are trying to do at this point of time is, see, when outlook is Sunny, we actually have to compare humidity. So what we do, we just ignore this column, we just consider that part of the table where Sunny is present, and we compare humidity. That is what is happening here. Now having this output in mind will kind of guide us what we are doing in the program. Okay, now we have understood what this call data means. What does this ATTR mean? Again, we have already explained this convention again before. Set of a list, what will it do? It will return the unique values. So if this call data is having no yes, something like that, then it will just return the unique value only. Okay, now why do we need this counts here? Counts is a again, it is a list, empty list containing only zeros. How many what are the number of lists we are creating? We are creating the number of lists which are equal to the unique values in that particular column. Now, in other words, by having this output in mind, now call is now outlook, and call data will have all the values where we have for every row in data. Okay, now call is what does this ATTR have? ATTR will have the unique values. Now outlook has only 3 unique values: Sunny, overcast, and rain. After that, what we are doing is we are having this variable called counts, which is nothing but a it will have a list for the each unique value in the column header. It looks a little complex, but which it needs to be understood. Now R and C are basically two variables, where R is referring to the number of rows and the C is referring to the number of columns in each row. Length of data of 0 means we are considering the first row, and we are considering the number of columns 1, 2, 3, 4, something like that. Okay. After that, for x in the range of length of ATTR. Now what does ATTR means? It is the number of unique values in the column data. Okay. So what we do, what we are trying to do in this part of the code is, we are taking the, for example, the ATTR is having the values Sunny, overcast, and rain. Okay, and now we take the first value, that is for Sunny. What we do, we go through the data set for y in range of R. R is the number of rows. If the data of y of column, what does this mean? Y is the row number, column is the column header we have got from the calling function. Data of y of column, if it is equals to ATTR of x. Now this has to be understood, this will be understood if we have paid proper attention. So ATTR, as I said, it is having the values Sunny, overcast, and rain. Now x value is 0, ATTR of 0 refers to Sunny. What it is doing, it is comparing if a particular row and if a particular item, that is row and column intersection, if it is equals to Sunny, then it is incrementing the counts list value. It is incrementing +1. Okay. Now why is this needed? We will just see here. Here what we do, we have created an empty dictionary called DIC. Now we are creating a key for each of the values in the attribute. Now DIC of ATTR of X. So ATTR of X means for each item in ATTR we are in a way creating the dictionary key. So this needs to be understood here. We are creating an empty list for j in range of counts of X. Now why this line of code has come will be understood if we have followed here. So counts of X is basically having the count of number of rows where sunny is present, number of rows where overcast is present, number of rows where rainy is present. Now this happens for every iteration, so it becomes meaningful. In the first iteration X will refer to sunny, next iteration it will refer to overcast, next iteration it will refer to rain. Okay, now DIC of, basically what we are trying to do here, for every value of the chosen column header, we are returning the contents. So we can see here for so this is just we are just initializing the dictionary item. Now position is equals to 0 will be understood later on. For y in the range of r, this is just iterating to the data set. Again we are making this comparison. If the data of y of column, if it is equals to ATTR of X. In other words, now the data set is sunny, we have 2 rows of sunny, 1 overcast, 3 rows of rain, again overcast. So it is not sorted. In other words, we don't have a few rows of sunny followed by few rows of overcast followed by few rows of rain. That we don't have. In all this function is trying to do is get that sort of information. So it is just processing every row, and if it is a column value, that is ATTR of X means it will be sunny for the first, that will be one type of values, and it will be overcast for the next type, and it will be rain for the next type. Now when will this delete be true? Delete is a, as I said, delete is a boolean variable. Delete will be passed by the calling function. If the delete is true, this line is self-explanatory. We are just deleting that particular data of y of column. We are deleting that particular item. That is what is happening in this line of code. If the delete is not true, we just have to append, or we just have to update the dictionary items. So dictionary of ATTR of X will be data of y. Now this is understood. And by position is incrementing, we are moving to the next. We are moving further in the data set. That is what is happening. In other words, as I said, this will ATTR, this function subtable will return the data set. Now that it will be returned in a format like ATTR is a list. What is list? What is ATTR? It is the unique values of a chosen column name. Now ATTR will be a list. So for example, for Outlook, ATTR will be sunny, overcast and rain. And what is DIC? DIC is a dictionary containing the rows in which sunny is, we have in a way dictionary is a sorted form of the data set. So that is what is happening in this part of the code, subtables. Now this will be understood if we revisit the program. This will need repetitive study and it will be clear. So basically subtables is just returning a part of the table, and if the delete is it is a boolean variable. If it is true, we are removing that. If it is not true, we are just appending to the dictionary and we are ultimately returning it. Okay, now we were going to this build tree function. We had come up to the point till here. Now so the subtable is returning something. After that, so we have got the data required for this step. Now the first step is already done. We have already created that node here. First step is done. Now for moving further, we did all this work we just went through now. Again, at this particular stage, again now we will have the ATTR updated. That means Outlook will not be considered here. ATTR will have these three: temperature, humidity and wind. So again it will just build the tree. How will it build the tree? We are calling the function build tree. It is a recursive function. Build tree is called. But now while calling the build tree, we are passing whatever we have obtained from the return value of the subtable function. So tic of att of x, and fpi is the updated features, that is excluding that particular attribute already chosen, whatever is the left, whatever is the remaining features, that is contained in this variable called fea. So it will return basically it will return a node. We can understand that build tree is basically returning node. There are two return statements, node is a object of type class node, and what is node? It is basically one node in a tree. Okay, now because it is slightly complex, it is often seen as the very toughest program, or the one which is very difficult to understand. But anyway, since we have understood every line of the code, this build tree function is now understood. So build tree, as I said, it is a recursive function. Whatever it did here, again it will repeat the whole thing. It will again, in other words, this algorithm is executed. So whatever it did for the first time, it found the information gain, and it found the attribute of the highest node, and it did the same thing, repeat until done. So the same thing is happening here. Outlook is the first attribute, then it will take the attribute called humidity, and then it will find the further attribute. If there are no further attributes, it will just find the leaf nodes, and then it will go to win. It will do the same thing. Basically, this build tree function is called repeatedly until we have the leaf nodes for every branch of the tree. Now we can see that ultimately the output should have only the leaf nodes. Leaf node will have only yes or no values. Okay, now we have understood subtable function. We have understood this build tree function. Now one of the important thing which we need to understand is calculation of entropy and this information gain. Now as I said, in this algorithm, in the first step itself, it says we need to compute the information gain. Now what is the meaning of information gain? It is present in the theory. This formula will be familiar to us if we have already learned the theory well. Okay, now the formula for entropy is already known. How will we implement in Python? So entropy is a function which will take a data set. Yes, you can just see here. Entropy is a function which is taking in the data set. Yes, what it will then do is, now we know that p plus is the number of rows for which the final outcome is yes, that is p plus, and number of rows for which the final outcome is no, that is p minus. That is all we are trying to do here. attr is equals to list of set of yes. Basically it will we will have the last column. We will basically s is just having the number of attributes. Okay, now S is basically, so S will basically have the last column data. What I mean to say here is, now this is the last column data. It is yes or no. Whenever it is only no or it is only yes, that means there is no entropy. What is entropy? Entropy is like a measure of dispersion. How is the data? It is basically a measure of similarity, we can understand. So if all the rows are yes or if all the rows are no, there is no entropy, there is no variation at all. So we return the value as 0. And this is a shortcut as well. In theory we follow the same thing. If we see only no or only yes, we just assume that entropy is 0. Otherwise we need the value of p plus and p minus. Now how it is implemented here, we create a list called counts, and we can see that there are two items in this list, 0, 0. So it can be guessed that first 0 refers to p plus, second 0 refers to p minus. Now what we do for I in the range of 2 means in other words we are just now updating the value of counts, because we need the value of p plus and p minus. Counts of I is equals to, now we have to understand this line of code very well. It is ultimately returning the sum of, so we can see that there is a list, 1 for x in s if attribute of I is equals to x. What does that mean? Now attribute of I, So I can take only values 0 or 1. So an attribute of I, an attribute of 0. So we can understand that basically this ATTR is a list of set of yes. It means S will basically have last column data. Okay, so now this counts list is calculating the number of rows for which the row is positive and number of rows for which the row is negative. So ATTR is basically having no arrays, so it will just have it will just create, it will just add 1 for every no row and for every yes row, and ultimately we are adding the we are returning the sum. In other words, every one is added. So basically it will have the number of rows in the data set. Counts of 0 will have the number of rows for which it is positive, and the counts of 1 will have number of rows for which it is negative. Okay, after that we see that there is a minus p of log p plus minus p of log minus. How will we going to implement it here? So this is also quite understandable for C and T in counts. Now what is counts having? Counts is a list which is having two things. It is basically having the information p plus and p minus. Basically they both are integers, number of positive rows, number of negative rows. So what we are doing, sums is a variable which we have initialized to 0. Sums is basically the final entropy value itself. Sums plus is equals to, what we are doing, minus 1 into count. Count is the first thing in this counts list. So now this CNT refers to this p plus math.log, so log of p itself, that is p plus log of p plus CNT log of CNT, and this comma 2 means it is log 2 base 2. So in the first step, first iteration, we are done with this part of the formula. In the second iteration, when the CNT value is 1, it will again do the same thing, and you can see that it is multiplied by minus 1 because the formula says so. Minus 1, we can take minus 1 into the whole thing. That is what is done here, and ultimately this variable called sums is returned as entropy of S. Now this entropy is called in this function called compute gain, because we can see that gain is basically total entropy minus this thing. So entropy is called here in the compute gain function. Now we have understood what this entropy function is doing. Let us now understand compute gain function. Compute gain function is also understandable if we know this formula. If you have understood this formula very well, what does this formula say? It will first need the total entropy value. So we can see that here total entropy is calculated. Entropy of for the entire data set, for row in data, considering the last column, we are finding the entropy. Now this can be written in the first step itself, but I prefer the same way for explanation. This is the first thing we need, entropy of S. Now for what data set we need to compute the gain, that will be known to us by calling the subtables function. So ATTR of ATTR comma DIC, we call the subtable function. We must remember that delete should be false here, because we are just calculating the gain. We are not deleting any particular item. So the subtables, when it is called here in the build tree function, delete will be true, but when we are calling it in the compute gain function, here the purpose of calling subtable is just to get a part of the table, so delete should be false. Okay, now as I said, the formula is very important to know. What we are trying to do here, total size is equals to length of data. So this yes refers to the total number of rows in the data set. That is what is happening here. Total size is equals to length of data. Okay, now entropy is equals to, now you can see that there is a summation symbol, and we are having the entropy for each value of that attribute. So this formula has to be understood. V belongs to the set of values of A, attribute A, what are its possible values. We need an entropy value for each of them. So that is done here. Next, ratio is basically this term. Ratio, initially we are just creating a zero arrays. Wherever we see this list like representation and zero in it, it is called zero arrays. So we are just creating a empty list. In other words, not an empty list exactly, but it is all having zero. And after that we will definitely update the value of both this entropy and ratio. We will see it here, but initially we are just having it as zero. And total entropy, as it is already explained, it is fetching the value of the entropy of the entire data set. Total entropy is equals to entropy of row of -1, that is the last column, for every row in the data. So we have just calculated this part of the code, this part of the formula. Now total entropy is done. Now how do we implement this part of the formula that is in here? For x in the range of length of attributes, ratio of x is equals to, now this becomes important, length of dic of attr of x. In other words, what is this SV means? SV means number of rows in the data set S where the attribute is having the value v. Now this has to be repeated again. SV, the modulus of SV means number of rows in the data set S wherein the attribute is having the value v. That is the meaning of SV. That is obtained here. Ratio is equals to length of dic of attr of x. The same thing, the same whatever I explained now, it is implemented here, divided by total size. Total size is what we have already got. Total size is nothing but length of data, that is number of rows. It will be 14 in the first iteration. Okay, now we have found the SV by S value ratio, and we need the entropies list. So entropy of x was initialized to 0 array, but now we are calling the entropy function for every row in the data set. In other words, dic of attr of x will return the dictionary. Dic is basically dictionary. Attr of x is for some value of the attribute. We are basically finding the entropy. Entropy is entropy of the data set for which attribute A with the value v. That is what is happening here. Entropy of row of -1 for row in dic of attr of x. Okay, now how is this summation symbol implemented? Summation symbol can be the summation is, in other words, is summation is we are just adding this term for every value of v. The same thing is done here. Now the total entropy minus ratio into entropies. So this entropies is basically having this entire thing. Total entropy is what we had beginning. Total entropy is the entire total entropy. There is entropy of S. You can see a minus equals to symbol here. So total entropy minus a ratio into entropy, that is happening here. And whatever is evaluated as total entropy is nothing but information gain. So that is returned as information. The variable is total entropy, but this is actually the information gain of the data set. So where does this compute gain work? It will be called in the build tree function. Now we have understood every function in the code except these two, print tree and classify. Now these are relatively much simpler. Print tree is a function which will just print the tree. In other words, now the final output becomes necessary. How are we going to correlate this output? So the decision tree for the dataset is as follows. Initially we consider the attribute outlook. Outlook can take three values: sunny, overcast and rain. Rain, overcast, sunny. It can be in any order. So what we do next, when it is rain, we check the parameter called wind. So when it is rain, we check the parameter called wind. If the wind is weak, it is yes. If the wind is strong, it is no. If the wind is weak, it is yes. If the wind is strong, it is no. So this part of the tree is represented here, and if the overcast is wherever we have the outlook value as overcast, whenever the outlook value has overcast, the final column will have yes. So that is represented here. Wherever it is sunny, we go to the next attribute, that is we chose humidity, and if humidity is high, it will be no. Humidity is high, it will be no. When it is normal, it is yes. Normal, it is yes. Now how are we printing this? This is done in this function called print tree. Print tree will basically take this to two parameters. First parameter is node, which is of the type class node. It is like every node is a tree. Okay, so print tree, basically what the entire function is doing, I have explained. It is so the spaces here are very important. So how do we understand that? After outlook we have three values: sunny, overcast and rain. There is single space. After going to rain, how are we representing it here? If this outlook is rain, we consider the parameter wind. So soon after rain, after a single space, we have wind. And if the wind is weak, it is yes. So after wind, we have given one space. So because it is not possible for us to get a similar image in the output, we need to represent the same by using spaces effectively. So that is done in this part of the code. Now this can be understood with the comments here. Node.answer, if it is not a empty thing, what I mean to say, now every node is having three things: attribute, children and answer. And answer will be initially empty string. Answer will be either yes or no only for the leaf nodes. So basically all these rhombus like structures are leaf nodes. So in this print tree, if it is not empty, that means if it is having yes or no, it is a leaf node, then what we do, we just multiply the number of spaces with the 11 and we print the answer we print the value of the node.answer and we return. Otherwise what we do is we just print the attribute name. So attribute name is humidity here, similarly it is wind here. So we print the we print the attribute name here. Okay, and this is not a one step thing. In other words, printing the ID3 is printing the tree is not for one step. It has to go further. So how are we going deeper in the tree? So we put a for loop and we process its children. So this is the first tree and it has children. So we do the same thing. We call the print tree function on the children of the tree. So value comma n in node.children, and we are calling the print tree function. So this function is what basically prints this. Okay, now classify function is what is called here. Now we had already understood this build tree and everything. Now let us just get into this plane of the code. After we have created the decision tree, we have something called as test tennis. Test tennis is also we will have a similar structure. We will just see it a little while later. Basically we are just again calling the load CSV function to process the test tennis CSV file name. After that, you can see the output here. We are just printing the test instance. So the test instances, so in the test tennis or CSV, the first row will be like overcast, hot, normal and weak. Overcast, hot, normal and weak. And the label for test instance, whatever we have printed, yes, that is predicted, that is not predicted, that is identified from by calling the classify function. So test instance is printed and the label for test instance, the statement is printed, the label for test instance is printed, but how are we getting the value yes or no? That is what we have obtained from the classify function. So this is what is basically making this part of the code work. So classify function is what is written here. How do we understand the classify function? Now this can be understood if we have kept the decision tree with us ready. In other words, now this is one instance of the test case, test 10s data set. We can see that the first thing is overcast. So what we can understand, it will come here, the decision tree, and the value of outlook is overcast, so it can immediately print yes. But that is happening here. It will just see, so what is classify node is doing. If it is a leaf node, it will simply print the answer. In other words, whenever it is overcast, it is basically it will have this node will have the answer as yes, and this node will have answer as empty string. That is what we have understood already. Whenever it is a leaf node, in other words, whenever the node has to represent the final column, only then the answer will have something. It will have either yes or it will have no. Otherwise, it will just have this empty string. Now, if it is not having empty string, we print the value itself. Now, that is why it is printed yes. Otherwise, now this is like the best case when we have overcast. But what if it is not having overcast? So then we will have to go further in the tree. So that is what I have written here. Go deeper in the tree. We will have to classify this. We have to call this function classify repeatedly or recursively. So what we do here, for every attribute. So in the data set, we see there is sunny. So from outlook, we have, if it is sunny, we have to choose the next attribute, that is humidity. So what it will do here, you can see that in the classify function, it is basically POS. So the next column header should be considered as humidity, and its value for value comma n node in its children. So this humidity will have two things. It can have high or normal, and if it is for every value, if it is high, for example in this case the value of humidity is high, so basically ultimately it will again calling this classify function itself, but when it is called there again, it will, this condition will be satisfied. That means the answer will have the value no, so again this will not be executed. So basically this is like a termination condition to this recursive function. So classify, it will call its n is the child node, so the next node in the tree, n comma x test. X test, as I said, is nothing but the what we have passed. X test is one instance of the test 10s dataset. This is x test, everything is x test basically. So it will, in other words, we are just calling the classify function for the same dataset, but we are going further in the tree. Initially it was just initially it would be outlook. If the answer is not leaf node, it is not a yes or no node, then we will have to go further in the tree. That is what we are doing here. We call the classify function again on the same node. It will go further in the tree, and the same instance, whatever we have classified, whatever we have passed, and features is nothing but the column names. And because the tree is already found, that is the tree is already found here. As I said, node 1 is calling this build tree function. Build tree function would have returned a tree. So basically it would have returned a node first of all. So classify is passing the variable called node 1. So node 1 is a node. So classify, initially it will be node 1, that means the first node in the tree. After that it will just go further. So it will node dot children, the children of the topmost node or this root node will be considered next, and we will call the classify function again. Ultimately what we are doing, we are just testing the instance for this particular decision tree, and we are finding the label for the test instance. Just we will consider one last example, and we will understand it completely well. So whenever it is rain, whenever the outlook is rain, we will have to compare the value of wind. Wind is the fourth attribute, so attribute is weak. If it is weak, we can print the value as yes. So whatever the decision tree is doing, the same thing is carried out correctly in the program. So that was the verification of the output. Now the entire program is explained. It is long and it is not the easiest of programs to execute, but knowing the program line by line will make it relatively easy. That was all in this video. Thank you. And this will conclude the AIML lab playlist. A video has been made for each of the 9 programs in the AIML lab, that is AIML lab subject. Thank you.